Hey guys, today we are going to have a continuation of our Crammers rule in solving simultaneous equation. So today we are going to have a 3 by 3 matrix, a 3 by 3 matrix. We are going to solve a 3 by 3 matrix using Crammers rule. So in our earliest video, we used a 2 by 2 matrix, but today we are going to have a 3 by 3 matrix. So let's have an example for us to understand this thing. Example. So example equation 1 is 4. Let's have this x plus 2y plus 3z, which is equivalent to 4. Then equation 2 is 5x plus 6y plus z is equivalent to 2. Then 2x plus 3y is equivalent to -1. So first of all, we have to form our solution. First we have to form a matrix using these three equations. This is equation 1, this is equation 2, and this is equation 3. So to form a matrix, we have to take a coefficient of every equation from each and every equation. So the coefficient of 4, x is 1 in the first equation is 4, then 2, then 3, then we are going to have 5, 6, 1, 2, 3, then here is 0 because we don't have z. Then this is our matrix. Then we are going to multiply by x, y, and z. This is, which is equivalent to 4 to -1. So having reached this point, so we are going direct to start solving this equation using Crammers rule. So I think let's rub here. Let's rub here like this. So I think even up to this point like that. So let's have this equation. So in solving Crammers rule, so we are going to have this 4, 2, 3, 5, 6, 1, 2, 3, 0. We are going to multiply by x, y, z, which is equivalent to 4 to -1. So mostly we are going to concentrate on this matrix and this one. So first of all, when you want to start to get the value of x, you're going to block this, the first column. You're going to block this first column, then you're going to bring this one here, block this one, bring this one here, then it will be 4 to -1. Then you're not going to alter this 2, then it is 2, 6, 3, 3, 1, 0. Then it's like that. Then you divide by the initial matrix. This one we're going to divide by the initial matrix, which is 4, 5, 2, 2, 6, 3, 3, 1, 0. So having reached this point, so we have to divide this, and dividing this, you have to get the determinant of this of the numerator divided by the determinant of the numerator matrix. So let's find the determinant of the numerator matrix. So to find the determinant of the numerator matrix, let's use the easiest way. Let's use this easiest way. It is 4, 2, -1, 2, 6, 3, 3, 1, 0. We are finding the determinant of this first matrix. Or let's put it down here like this. Let's bring here 4, 2, 1, 2, 6, 3, 3, 1, 0. So to find the determinant, you find. So this is a negative. This was a negative. I forgot. So this is a -1. So we are going to bring these two rows. We're going to extrapolate these two rows and bring it here. 4, 2, -1, 2, 6, then 3. Then you're going to multiply these rows, these diagonals, this diagonal, this multiplied by this, multiplied by this. So it is 24 multiplied by 6 multiplied by 0, which is 0. Then 2 multiplied by 1 multiplied by -2 is -2. Then 3 multiplied by 2 by 3 is 18. This is our main diagonal, primary diagonal, according to this. So we are going to add this. It is 0 plus -2 plus 18, which is going to be -2 plus 18, which is equivalent to 16. So coming to this also, we are going to multiply this -2 by 6 by 3, which is -18. So we are going also to multiply this diagonal, which is 12. Then we are going to multiply this, which is 0. Then we are going to add -18 plus 12 plus 0, which is going to give us -6. So up to that, then you're going to subtract. This is our main diagonal. Okay, so after we have solved this is the major principal diagonal. This is the value for principal diagonal. So we are going to get, as always, it is principal diagonal minus the primary diagonal, which is 16 minus -6, which is going to be 16 plus 6, which is 22. So that's to mean the determinant of this numerator matrix is 22. So we have gotten the determinant for numerator matrix. So we are going to get the determinant of the denominator matrix. Let's try this. I think you're okay. So let's get the determinant of this denominator matrix, which is 4, 5, 2, 2, 6, 3, 3, 1, 0. As always, we are going to extrapolate these first two rows, these first two columns, this one and this one. We are going to bring it here. 5, 4, 5, 2, 2, 6, 3. Remember, we are finding the determinant. So let's start with a primary or principal diagonal, which is 4 multiplied by 6 multiplied by 0. It is 0. Then 2 multiplied by 1 multiplied by 2, which is 2. Then 3 multiplied by 5, 3 multiplied by 5, 3 multiplied by 5 by 3, which is 45. There we go. So I'm sorry, here is 2 multiplied by 1 multiplied by 2, which is 4. It is not 2, it is 4. So let's come to the secondary diagonal, which is 2 by 6 by 3, which is going to give us 36. Then 3 by 1 by 4, which is going to give us 12. Then 0 by 5 by 12, it's going to give us 0. Then we are going to add. Let's add this, the value of principal diagonal, which is 0 plus 4 plus 45, which is going to give us 49. Then let's come also to this, which is 36 plus 12 plus 0, which is going to give us 48. Then as always, you're going to get principal diagonal minus secondary diagonal, which is 49 minus 48, which is going to give us 1 as the determinant of the numerator. So having 1 as the determinant of the numerator matrix, so we're going to get, here is 1, so we're going to get 22 divided by 1, which is going to give us 22. That is 22. This 22 is going to represent the value of x. So that's to mean we have gotten the value of x. This is the value of x. So let's go again to get the value of y. Remember, we've gotten the value of x. So let's go to y. Y also we are going to get. We are going to this. We are taking this matrix. Our concentration is in this second column. So we are going to close this second column. We are going to close this second column. After we close this second column, we are going now to bring this final answer to that point. So that is to mean it is going to be 4, 5, 2. Then we are going to close this one and bring this one here, which is 4, 2, 1, then 3, 1, 0. This becomes the numerator matrix. Then we are going to divide by the initial matrix, which is 5, which is 4, 5, 2, 2, 6, 3, 3, 1, 0. So for always we are going to find, we are dividing the determinant. So that's to mean you're going to find first the determinant of this numerator, then you divide by the determinant of the denominator. And remember, we have already found the denominator of this, the denominator, which is, we have gotten it is 1. So our concentration is always going to be on the numerator. So let's divide, let's find the determinant of this matrix. So it is going to be 4, 5, 2, then 4, 2, 1, 3, 1, 0. These are matrix. Then, as we have said, you're going to extrapolate this first row, first column, these first 2 columns, and we're going to bring it here, which is 4, 4, 5, 2, 2, 1. Then we are going to multiply. We're going to first multiply the main diagonal, or the principal diagonal, which is going to be 4 multiplied by 2 multiplied by 0, which is 0. Then 4 multiplied by 1 by 2, which is 8. Then 3 multiplied by 5 by 1, which is 15. Then add 0 plus 8 plus 15, which is going to give us 23. That's for the principal diagonal. Now go to the secondary diagonal, which is going to be 2 by 2 by 3, which is 12. 1 multiplied by 1 multiplied by 4, which is 4. Then 0 multiplied by 5 multiplied by 4 is going to give us 0. Then we are going to add 12 plus 4 plus 0, which is going to give us 16. Then after you've gotten this, you're going to subtract to get determinant 23 minus 16, which is going to give you, this is 7. 7, I think it's 7. So for this is 7. So you're going to get 7 divided by 1. So after I've gotten 7 divided by 1, this gives us, so remember there was here a negative here, there's a negative here, there was a negative here which we forgot, and also there's also, we have put this negative here, so and this also is a negative here, negative. So I think we have first to rub this one, After rubbing this one, let's now look for it. So here we have said it's a negative, so we're going to multiply this by this, which is going to give us 0, 8, then 3 by 5 by negative 1 is negative 15. Then this by this is going to give us 12, which is correct. Then this one, negative 1 by negative 1 by 1 by 4, which is going to give us negative 4. Then here is 0 by 5 by 4, which is 0. So we're going to get 0 plus 8 plus minus 15, which is going to give us 8 minus 15, which is negative, this is negative, I think this is negative 7, yes. Then this one is going to give us 12 plus minus 4, which is, this one is 8. So you're going to take this, main determinant, this is the main diagonal, this is the value for the main diagonal, so it is negative 7 minus 8, which is going to give us negative 15. So that should mean our numerator, the determinant of the numerator is negative 15, which you are going to divide by 1, this matrix, the value of this matrix, which is going to give us negative 15. And this negative 15 is the value of y. So y is equals to 15. That is it. So we have finished this one. So we are going again to effect this. So we are going to rub its action. So we are going again to effect also this one also, so as to get the value of z. So that is to mean, as always, we are going to block this. We are going to block this here and bring our results here. You see? Let's rub this. Block this, then you bring the results there. So like you block like that. So it is 4, 5, 2. This is